I guess it's about time, so let's start. Yeah. Mad Science Jazz, you want to do what with JavaScript is the title of this presentation. And saying now. So just before I start, I did presentations with the same title a few times, but they always have different content. So sometimes it's like playing around with the Kinect, sometimes it's a bit like capturing video and stuff and doing crazy canvas whatevers. This time it's about this little thing here, but we come to that later. So first of all, for those who haven't seen my talk this morning, the other one, hi, I'm Sebastian, still working at Denkwerk, Germany, Cologne. I consider myself as the average JavaScript dev from next door, so nothing special, just like JavaScript dev, you know. On the internet, you can find me on GitHub, Twitter, Vimeo, Flickr, everywhere under ASCII Disco. And I love coffee, 80s movies, and multicolored socks. So my favorites at the moment, if you know where to get cool multicolored socks or ones with dragons on it or snakes or something like this, please ping me via Twitter. I really appreciate that. Also, yeah, my company also loves JavaScript, and I have some stickers with me. So if you want to have some I love JavaScript sticker, just come to me after the talk, grab some. So yeah, but back to topic. A bit of history. So when I was like a kid, like 5 or 6 years old, I always dreamed about like being some kind of mad scientist with a lab coat and big glasses. I mean, at least I got the glasses. And later on, I discovered JavaScript. So a few years later, let's say 20 or so. And nowadays, it seems that like everybody loves robots. Like it's the same movement like back in the 80s when you have all those crazy 80s movies, robots everywhere. Now it's like landed in JavaScript world, and we have like this crazy JavaScript robots flying AR drones controlled via the browser. And yeah, so it all kind of started with this little thing with the ARDUINO, and this is like the key to the robot world that was hidden behind doors watched by scientists. Like always, we're big scientists from universities and we build robots. And now we can say, hey, we're JavaScript developers, and we can do that too. So yeah, first of all, meet the ARDUINO. It's like a microcontroller for everyone. This is actually the new one. It's the ARDUINO Due, so it's from Italy. I've got the older one, the ARDUINO Uno. As you can see here, it has some multiple analog and digital input and output pins. You can just stick stuff on it. And it has some power supply, so you can grab 5 volt or 3 volts out of it. And you can connect it to your computer via USB, or you can just let it running standalone, powered by some battery pack or a power pack. Yeah. The ARDUINO itself is a tool for making computers control and sense the physical world. So it's like a bit like eyes and ears, or more the skin of a computer, so it can just like collect data from the world outside this box here, and lets us as developers then do something with this data. Yeah, as I said, ARDUINO projects can be standalone, or they can communicate with any software that is capable of grabbing data from the serial port or the USB port on your computer. So that's like nearly every programming language can do that. And it's inexpensive. So The Arduino itself, the Uno, is between 20 or 25 euros on Amazon. So you can order it, and within the next day, you're having your own little microcontroller. Works cross-platform, so it doesn't care if you're working on a Mac or on a Windows machine. You guys can't see that, but yeah. It's totally cross-platform, and it's open source. So even the hardware layouts, if you go to the Arduino website, you can find the schemes there, and maybe just buy the parts if you really want to freak out and build your own Arduino based on a scheme presented on this page. Yeah, also a lot of third-party extensions. So they're called shields, and you have like LCD displays, network adapters, even a 3G adapter. I don't know what to do with that one, but definitely there's somebody that can do something with a 3G adapter on that thing. You might ask yourself, so yeah, we're on a JavaScript conference, and that fits better. We're on a JavaScript conference, and this guy is talking about this hardware thing and doesn't show some code and even not a single web page or whatever. Hey, we're on a JavaScript conference. Again, a bit of history. This one's a bit newer than my childhood. There's a library for Node out there. It's called Node Serial Port. It was born on September the 7th of 2010. Coincidentally, that's also my birthday, September the 7th. It allows to bidirectional communication via the USB port using the serial port protocol. So after that was put out by our beloved dictator Voodoo Tiki God, Node.js was able to just like receive and send data over serial ports or over the USB port. And well, then some people thought, wow, the Arduino can be controlled via the serial port protocol or via the USB port. Maybe we can do something with that. And yeah, you might think, so isn't that difficult? Like hardware and things, and JavaScript and stuff. And, oh, I just messed something up, sorry. Wrong button. So, this is actually the logo from the Johnny 5 project. This is a Node-based project, which is then based back on the serial port, that allows us to connect or program the Arduino or control it via JavaScript and use JavaScript APIs for that. So, yeah, it has a super slick API. This is like behind the Johnny 5 library, there's some jQuery guys like Rick Walden or Rebecca Murphy, and typically those people are very good at designing APIs, and it's like, this is so easy, like connect to a board. Okay, make a new board instance. Then connect to an LED. Well, we just make an LED instance and say, hey, the LED is attached at pin 13. And then we say LED on, and the LED should go on. We will see that it really works in a minute. So again, thanks Rick Walden and all the other contributors. They've done a really good job on this project. You can find it on GitHub. Rick Walden, Johnny 5. Even if you don't own an Arduino, even if you're not really interested in this topic at all, please just make sure you check out the videos. It's really funny. Yeah, again, hardware and stuff. Difficult, wire up things, program it. I never done that before. I'm just a web page JavaScript developer guy. Well, no, this is absolutely easy stuff. So I guess now it's time for a demo. By the way, blink tag is gone in Chrome. You need to polyfill it. Marquee with a scroll amount of 100% is your friend, for sure. So yeah, about, yeah, that's me. About a little application, like some kind of dashboard for Arduino-related things. And, okay, let's see if we can use the camera. Okay, that looks good. So you see, there are like changing numbers. They're like big round dots that stand for the LEDs that are connected to my Arduino. And now I can just like tap here in the browser. It's like lighting something up. I can say all off, all on, toggle, all this lovely stuff. Disco flashlight. So don't clap when you see how easy it is. You just no, thanks. And also, there's a temperature sensor attached to your Arduino. That's okay. Let's see. That's this one there. It's not easy. I don't see it myself. So this here, this is the temperature sensor, and the other thing that you see here next to the LEDs, this is a brightness sensor, so photoresistor. And okay, back to the setup. Just take a look at the temperature. Normally, when I should, hopefully that doesn't sound awful through the microphone. Just throw some fresh air on it. It cools down, and then the temperature changes immediately. Same goes for brightness. If I just like get my finger on the photoresistor, brightness just goes down because there's less light reaching the photoresistor. And now finger off, we're back again. You might want to know now how that's gonna be working, how the code looks behind it, and also maybe how things are wired up on a microcontroller. So I zoom a bit in. No Mo Tim. That's it. Okay, yeah. Again, zooming. Here, this is a schema of the Arduino, and there's like one LED attached to pin 13, and also the LED is attached to the ground. So else, normal basic electronic stuff, without the ground, nothing works. So we have electricity circle closed. And to light this LED up from node, you just need this, zoom out, code. So you, like you always do in Node, you require something. In our situation, we require the Johnny 5 library. Then we say, okay, we instantiate a new board, because this, like, the board is the Arduino where the LED is attached to. And this also automatically discovers the USB port the board is attached to. So it goes all over your USB and serial ports in your computer asking, hey, is there an Arduino? No. So you're not the part I'm supposed to talking to. And it goes up and up and up until it finds the Arduino and the attached port. And then it establishes a connection. So when this connection is established, a ready event will be fired on the board. Again, this looks very jQuery-ish, because jQuery core developers designed the APIs. Also, it's really cool because it's all asynchronous, and JavaScript and asynchronous and happiness. After the board has been initialized and the ready event has been fired, you can go and create new hardware instances. So in our situation, we instantiate a new LED, say, hey, LED is attached at pin 13, and that's it. After that, we can just say LED on, or LED off, or LED toggle, and it will go on, off, or it will toggle. Easy. Nearly the same as for sensors. So an LED is attached to digital pin because it just takes two arguments, or at least it takes one argument, and the argument is 0 or 1, because LED is on or LED is off. With sensors, this is a bit more difficult, because normally sensors like the photoresistor or temperature sensor are analog sensors. So they have a wide range of values that they can represent. It's not like we have no temperature or temperature. No, we have some degree. So also this is the scheme for actually the photoresistor. Photoresistor is attached to analog input pin 2, and we have like the 5-volt power supply attached there, and have also a resistor, else the sensor will just like go up in flames. I know because my first temperature sensor just like in the end had over 100 degrees Celsius and then it vanished. So you have to learn something about electronic stuff and resistors. Just don't go and attach everything to 230 volts and melt your flat or your living place. No, just don't do that. Here is a simple sketch. So we have the resistor wired up with the power supply, have an analog input, have it all wired to the ground, and then we program it. Again, Johnny 5, board is ready. We say, hey, Johnny 5, I want to have a new sensor, because we have various different sensors that we can attach. It's connected to the analog pin 2, and I would like to ask you for changes in a frequency of 250 milliseconds. So then Johnny 5 goes every 250 milliseconds and asks, does the value change? Have the value changed? Have the value changed? And on change, if the value of the photoresistor changes, there will also be an event fired, which we can grab the current value. Then you have to do some math or dig to Google and copy and paste some math to get what you want out of it, because you're becoming, in case of the photoresistor, you're receiving a value something between 0 and 700. And first time I just like console logged the value on every change, it was like, okay, everything from 0 up to 700, what am I supposed to do with that? So, but other way smarter people have figured it out like 1 million years ago, back in the 70s, and you can just get their math stuff, copy it, and calculate at least some kind of percentage value or something like this. Or you're smart enough yourself and like math stuff, then figure it out on your own. In our case here, in we're updating stuff in real time, or nearly in real time, and that's pretty basic socket I/O stuff. So we're using WebSockets, and every time the photoresistor changes, for example, we're not doing a console logging of the value, we're just emitting a WebSocket event and saying, hey, photoresistor changes, new value, and browser will receive that and say, yeah, updates itself. So, interesting. And here in the front of the room, it's way colder than in the back. Why do I always want to do that? So, why? Yeah, why is a good question. So after I first came up with this little experiments and showed it to some colleagues and friends or at a local user group, people came up to me and asked me, why you're doing this? So first of all, because I'm having fun doing this, and otherwise I would be bored or should have working on real serious open source projects. No. But I have even a different point of view. So in our company, we're working together with some students, universities, schools, and like 3 or 4 weeks ago, we had a couple of girls from a girls-only school over at our place that are interested in becoming like designers, information architects, or programmers later on. Well, not that much girls wanted to be a programmer, but I hope I just like have changed their minds, because I did a presentation, I had some stuff, the Arduino, but also other stuff like the Makey, if you know that. And the girls then saw that this stuff can make fun. It's not like, oh, you have to do this. I'm not doing the math thing again. You don't have to do hard calculations all over the day to program. You can actually have fun programming. Same as for little cousins of mine who are like just only playing computer games on computers. But with this kind of stuff, you can really attract them also to programming, and can get kids and people who are actually not really interested in this whole web or JavaScript stuff into it. And that became one of my goals in all of these presentations, besides conferences like this, to just get people into not even JavaScript, but at least programming at all and having fun with this stuff. And that's maybe that's the answer to the question why. Sebastian, why you're doing this more or less useless stuff. So I guess that was all, and I'm really extremely good in time, so before I say thank you, questions, anyone? So question was, can you trigger in some way high voltage output with the Arduino? So there is an open home automation project. It's called OpenHub, and there are some schemes and some sketches for Arduino controlled power plugs. So you can attach relays to the Arduino like you would like with normal electronic stuff. But don't do that if you're inexperienced with electronics, because this is serious stuff. It's like 230 volts, and a lot of stuff can happen if you do it wrong. But it's possible. Yeah, you can attach, like bypass the 230 volts, and then just use the Arduino to switch on and off the relay, and then you can just nearly control everything. If you just take a look at YouTube, there was some guy, I don't know if it's the same here in France. So in Germany, you can buy at like random supermarkets wireless controlled power plugs for like 10 euros. So we have this remote control, and you can control free wireless power plugs. And actually, the cheapest thing you can do is buy that one, open up the remote control and wire that to the Arduino, and you can control at least 3 power plugs with the Arduino, because these remote controls mostly have an input pin, and you can just say, okay, I'm using the Arduino remote control library from Google projects, and then using that with a web interface to turn power plugs or lamps or whatever can be stick there on and off. So that's the easy solution. I did that before I fucked the remote control up with too many voltage. But different story. All learnings. Yeah, definitely. So 1 week ago, I wasn't aware of that too. But then Rick Warden said to me on Twitter that it's actually possible. So you can, at least with Johnny 5, you can say, okay, discover different boards and then give them IDs. So ID 1, 2, 3, 4, 5, for example, and then you can wire up as much Arduinos as you want. You can have like a whole Arduino army connected to your PC. Anyone? No? Cool. Oh, no, there. Cool.
Do you have any plans to provide a way to use it with something like a Raspberry Pi?
Actually, I have a Raspberry Pi at home, and I wired up the Arduino with the Raspberry Pi, then compiled Node on the Raspberry Pi, and then use the Raspberry as a server to control the Arduino remotely over the internet. So that's no problem. I know that the Raspberry Pi itself has similar capabilities when it comes down to controlling input and output stuff, and it has analog and digital in and outputs. And I haven't seen a JavaScript-based library for that yet. I've only seen Python-based libraries, but I guess it's just a matter of weeks until a JavaScript library comes out that you can run on a Raspberry and control the pins there. Yeah, actually, there's a guy working on a shield for a Raspberry Pi that you can then plug Arduino shields on the Raspberry Pi, so that every third-party hardware for the Arduino can be used with the Raspberry. But this is in early stages, so he just came up with a basic sketch, and this is nothing that's been in production. So, no more questions? Then I can say thank you. I hope you had some fun and felt inspired. Thanks. Also, don't forget the stickers.
Actually, I have one question.
Oh, that's going to be hard.
Why do you have 5 up?
Why I have this t-shirt? They came to a Cologne JS meetup and asked some tricky JavaScript questions, and I answered them, and then I won a t-shirt. And it looks just cool, so I wear it.